And also, formula sheet you need to remember. Formula sheet you need to remember. Find a blank spot. Find a blank square. Whatever gets the job done. Okay, everyone's got a blank square. You can fit both of these in the same one. Exponential growth and exponential decay formula. All right, let's start with exponential growth. Okay, problem involves exponential growth. Here is the formula we'll be using. It is P times 1 plus R to the T. Pretty simple one, even though I say that and you're on like the 17th formula and to remember. What's P again? P, principal, your starting amount. R, rate as a decimal. T, time. Okay, and then if you know that one, you're going to know decay. Exponential decay. Guess what's the only part of this I'm going to change? It's going to be 1 minus the rate to the T. All right, so there you go. Let's go back to number 30 now. Growth or decay problem? Growth, so I'm going to need P times 1 plus R to the T. It starts talking about minimum wage. Starts talking about minimum wage. 1966, hey, $1.25, everybody. $1.25. And then in 2015, $8.75, which I think it's more now, right? 10, 11? Is it? Somebody said fifth period was going up to 11 soon. Okay. But hey, $1.25 back in 1966, huh? Whew. So from 66 to 2015, at what rate did it grow? So which variable are we going to solve for here? We're going to solve for R. Let's set it up. What's my P value? What was my initial amount? $1.25. 1 plus R. We're solving for R. Ooh, how do you find that time? Yep. Subtract what, Kylie? Yep. How many years between 2015 and 1966, everybody? How many years between the two? 49 years. All right, I got to set it equal to something because my variable's here. So it's got to be set equal to what? Well, how much did it change in 49 years? To change to 875. That's the ending amount over there. All right, now this is the first time we've done this because usually this R value would maybe be in the exponent. You're like logs, logs, logs. Let's roll. It's not going to be logs though. It's not as an exponent, but I still need to solve for it. Thoughts? You're going to be right. You're going to be right. Thoughts on what to do here first? Jason, come on. Yeah, get the $1.25 out of there. Get the 125 going. Oh, that's a nice whole number if you find it right now. What do you got? 7. 1 plus R to the 49. Okay, here's where you got to put your big boy, big girl algebra 2 pants on. How do you get rid of that 49? Because you're not ready to move over the 1 at all. How do I get rid of that 49? Anything? Take a shot in the dark. Here you go. Ready? This will answer the question, hopefully. What if I had R squared equals 7? What would you do on both sides? Take the square root. Well, it's not raised to the second, is it? It's raised to the 49th. So I'll take the 49th root. Yep. That is nuts. I know. It is nuts. Okay, so taking the 49th root on the right side just gets rid of the 49 and leaves 1 plus r. That's why we have calculators. Now, I don't know. Check your own calculator. Some of you have to type in 49 first and go to math number 5. Some of you can just go to math 5 and type in 49 in the root yourself. Figure it out right now, what you have to do on your calculator. Figure it out. And then everyone see that beautiful decimal? You're not touching it. You're not going to round it. You're just going to write it out for us. Let me know if you're having an issue with the calc, please. All I know is I'm going to be one disappointed person if you don't know what's going on with your calc the day of. All right. Still need to solve for the rate. How? This is the easy part now. Yep, subtract 1, everybody. Get the 1 over. R is going to be equal to 0.0405. How do you think I leave my answer? Read the directions. Go back, take a breath, read the directions. It says nearest percent. Nearest percent. That's a decimal. Times it by 100. Yep, and round that sucker. So my rate for this problem, 4%. 4% increase. Guys doing all right? We good? We're ready to keep grinding on here because this might be the most intense week here. I got to try to fit everything else I forgot about. 33. Okay, everyone stop. Don't try to write anything down. Do you see how this involves fractions? If it involves fractions or radicals and you're solving for a variable, let me say that a little slower. If it involves fractions or radicals and you're solving for a variable, you need to check your final answers. All right? You need to check at the end the final answers if it involves fractions or radicals. Okay? Because this test, whew, boy, they love putting a good one and a one you got to reject. Not saying that's going to happen here, but for future notice. All right, common denominator. Yeah, this is an easy one for common denominator, I think. What do you got? P minus 5 and both of them together. You can't separate the P, it's attached because of the minus and the plus. So my common denominator, here we go. Boom, minus, boom, equals, boom. P minus 5 times P plus 3. P minus 5 times P plus 3. P minus 5 times P plus 3. Anybody want to ask, well, what if they had this attached to it? Or what if they took this away? Anybody want to ask anything now? Because I don't know if we'll be doing another one here at all. We're all good? Okay. You're up now. What do you got to multiply that 3P by in the numerator? What's it missing? P plus 3, up. Whoop. What do you got to multiply the 2 by in the second one? What's that one missing? P minus 5. Stop me here, guys, if something doesn't look right. And finally, what are you multiplying the P by on the other side of the equal sign? P minus 5. Once you've done all that work, bye-bye denominators. Bye-bye denominators. Once you've gotten the common denominator, multiplied the top by what you need to, bye-bye denominators, and you're just solely looking at the numerators now. So little distribution here. First up, 3P squared plus 9P. Here's where the trap happens. What's the trap? That you're going to be better than and not fall in. What's the trap? You're not distributing a 2. Distributing a negative 2. Distribute the -2. So yeah, you'll probably write down minus 2p. Oh boy, but you might write down minus 10, but it's plus 10. And then over here, p squared minus 5p. I'd probably do a little cleanup. Man, how awesome would it be if you guys just come in here the Monday after, and I can look at everybody and just say, yep, it was a difficult exam, but you all passed. And just a riot breaks out. And if I don't say that, you can figure out who didn't make the cut. Because I'm certainly not saying a word. Next move. Mom, next move. You got it. Yeah, one side equal to 0. So let's move the p squared and the 5 over. So I'll have 2p squared. What happens when I move that 5p over? Plus 12. Oh, 12p, excuse me. Plus 10. All right, before you start hitting that quadratic formula button, take a look real quick. Don't hit that button yet. Yeah, let's take out a 2. What happened? Oh, now we're getting crazy now. There we go. Take out a 2. Oh, yeah, you don't need the quadratic formula now. Once you take out a 2, I hope you don't. Anybody find 2 magic numbers? P, 5 and 1, both positive. So my 2 answers I'm going to get. Now take a look. Somebody asked 5th period. Well, you took out the 2 and you never did anything with it. Does it have a variable? Okay, good. Well, here's what you're going to write. 2 equals 0. Does that make any sense? No. Okay, so unless you take it out with a variable, you don't need to set it equal to 0. All right, 2 is not part of my solution. What is? P equals -5 and -1. And for time's sake, today, I'll tell you if it works or not. All right, but day of test, you need to plug it into the left, make sure it equals to the right. Store those suckers in. And both of them do work in this case. Okay, both of them do work. Yes? Yep. You could. You could, because then you're going to get 0 divided by 2 and it's gone. Yep. Yep. That's fine. Anything else going? 4-pointer right there. Just check the darn thing. All right, last one we're going to do together. Yep, we're going right for the big dog. Right for the throat. 37. 6-pointer, you're not leaving it blank. You're going to get all 6 or as many partial points as you can. All right, first thing we're going to do, I'll let you read through the problem. We are not going to graph it, though. We don't have the time, and I have full confidence, excuse me, that you can plug that into your calculator and graph. Okay, I got full confidence, and you can set up an X and Y axis. Full confidence, but please just read through it first so we know what we're dealing with. Because you're going to have 2 functions. You got the value of the car and the loan he's got to take out. Question for you guys. When you go to graph it, because you will eventually, because you're going to do hardcore reviewing, what are you going to set up your x-axis on? How are you going to set up your x-axis? Read the problem. Yeah, 0 to 5. Nice job. All right, from 0 to 5. All right, so everyone turn the page for me then. Turn the page. You can graph it on your own. I got full confidence, like I said. All right, when are these 2 equal? When are these 2 equal? And remember, you just graphed it. What can you do? Yep, where they intersect. Let's go. Y equals y1, y2. Let's find out where these graphs intersect so we can answer this question right from our calculator. Take your time. You got a lot of digits there. A lot of digits. 2, 8, 2. And you guys go to graph, you're not going to see a darn thing. Not going to see a darn thing. All right, let's adjust our window. Definitely on our window, what's our x's have to go from? 0 to 5. So make sure you go to your window right now, 0 to 5. Okay, not really too sure about the y's, and I don't want to start guessing because I could be here forever. Or can I at least get a little taste of what the y values are? Table. So everyone go to the table. Go look at 0 to 5 on your table right now. Look at 0 to 5. Whoo, buddy, huh? At 5, I'm looking at about 4,200 here. And at 0, I'm looking at about 28,000. So you guys give me a good range of y values to put my window at. Doesn't have to be exactly those. I prefer they not be, but what's a good y window range here? 4,000 to 29,000. Everyone all right with that? Okay, let's see. So window, y min, 4,000. Y max, what did we say? 29. Hey, you know what? And if you can't see it, okay, you can go back and adjust it. You know, it's not a one and done. Oh, there you go, Gabe. There you go. How do I find out where they intersect now? Ooh, second trace. God, we better be beasting this thing. Intersect. Get old Spidey to the point of intersection as close as possible. And then first curve, yep, enter. Second curve, yep, it's on there, enter. Let's get a little guess. Now the question is, which number do you want? Which number do we want? What are we looking for? State when v of t equals z of t to the nearest hundredth. So when t equals, t's the time. Is that our x or our y values, the time? Those are our x values. So 1.95, 23346, but rounded to where? Nearest hundredth. So it'll be t equals 1.95. Remember, if we use something like intersect maximum, what do I have to write? Because you showed no work here. I used the calculator, I graphed it, went to second trace, selected intersect. Got to write that down. All right, and then we will finish this part C tomorrow. All right, but nice job, though, today, guys. Nice job. We're getting there.